Hey guys, Troy Miller from Logic BMS here. In this video I will be going over how I built a humidity alert system that is being used to monitor temperature and humidity for hay farming. The idea is that when you bale hay, it needs to be during the night and when humidity is over 60%. Hay farmers tend to lose sleep waiting to see when the humidity is just right to go out and bale their hay. I was asked if I could build a device that would monitor conditions out in the field where the hay is on the ground waiting to be baled, and then send an alert to the farmer from these remote locations once optimum humidity is reached. I spent some time researching a bunch of hardware, software, and other components, and here's what I came up with. I start with a Raspberry Pi Zero connected to a 2500 mAh battery hat, a DHT22 sensor, a DHT11 sensor, a Pi fan to move air past the external sensor, an LED light with a 1K resistor, a 10,000 mAh battery pack for more power, a 4G mobile hotspot for connectivity, some Velcro tape, and some various sizes of hex-style post stands, and finally a weatherproof field box to hold all the parts. I used Raspbian and Jessie Lite for the operating system, installed on a 16GB micro SD card, Node-RED to run all the programming, and output this cool dashboard to monitor the data. And also to integrate with FarmOS, which is a really cool farm management framework built on Drupal 7. I use Mosquitto MQTT Message Broker to send alerts and further extend the capabilities of the system, and as you will see later in the video, I also use email to send text alerts to cell phones. So what do we got? The requirements for this device included being able to send alerts to other devices. It needs to not attract too much attention to itself when placed out in the field so that it doesn't arouse the curiosity of passers-by. We also need to be able to control it with text messages and be able to make a blinking light visible on command so that it will be easier to find at night. That way it doesn't end up getting run over by the tractor. It also needs to be weatherproof while still being able to measure humidity conditions. So after lots of thought, some trial and error, and then some Liquid Nails weatherproof sealer, here's what I ended up with. In this next clip, I show you how the outside sensor is configured in Node-RED. So what you're looking at here is the Node-RED dashboard that I have installed on my 1&1 cloud server account. It is displaying the data that is sent out from the Pi to the MQTT broker. It's important to note that I have two instances of Node-RED running. One is on the Pi and the other is on the cloud. They send message payloads back and forth to each other through the MQTT broker, which is also running on my cloud server. Here I go over the flow that is installed on the Raspberry Pi that controls the DHT22 sensor. First, it starts with the inject node that runs on a time interval. Next, it goes to the DHT node. From there, the temperature and humidity payloads are separated using function nodes. Next, I use the change node to set the message topic to something that looks better on the chart and joins the two message payloads together, which then displays the values on the chart that keeps a 72-hour history of the data. The message payloads also get passed along to be displayed by their respective gauges for temperature and humidity on the Pi's local network. Furthermore, the message payloads are sent to a join node where all the data that comes out of the flow is parsed to be sent out to the MQTT broker, which will then be received by the instance of Node-RED that is running on the cloud. You follow me? If not, that's okay. Hopefully it will all make sense by the end of the next video. In this next clip, I briefly go over how I set up the Raspberry Pi to send alerts using an email node. I should mention that it's also possible to use a similar configuration to send message payloads to an MQTT broker that could then relay the alerts or use payloads to trigger other events. In this flow, I basically use an inject node to start the flow to the sensor node and the alert status node. If the alert status is on, it sends the payload of true. If it's off, it sends the payload of false. Once the flow gets to the switch node, the value of the humidity level is routed to the proper output. If the value falls in the range of the alert, it is passed to the email node for the alert to be sent. If not, the flow stops and nothing happens. A similar process is used to send alerts if the battery gets too low. The Pi can also receive messages from an email account that is set up for it. At set intervals, the Pi goes and checks the email account to see if there are any new messages. If a new message is received, it is downloaded and sent through a switch node and routed to the proper flow. This allows the user to turn off or on the alerts or blink the lights on the Pi from a text message or email. For example, if the user sends the message alert off, it will turn off the alert system and send the user a confirmation message that the alert system is off. Another example is if the user sends the word blink, it will blink the light for 5 minutes. If they send the word stop, it will stop the blinking light. We use the same method to send commands to shut down or reboot the Pi. So, that's it for now. In part 2, I will go over in more detail about how we can control GPIO pins on the Pi to blink lights or even control relay boards and servo motors. I will also go over how to use an HTTP request node to send data to FarmOS and have it logged to the MySQL database, and how to set up a heartbeat alert on the cloud server so that if the Pi goes offline, it will send the user an alert. I will also go over how to get the CPU temperature and battery level from the Pi and how to display them to the dashboard. If you have any questions or comments, feel free to reach out to me through the comments box or through the website logicbms.com. I would be interested in hearing any feedback you have about this project. Thank you for watching this video, and if you like it, please consider hitting like, subscribe, follow, or share.